adding and subtracting rational expressions with unlike denominators. What is the most important skill needed for adding and subtracting unlike denominators? Well, it's finding the least common denominator. If you can do that, then doing this is very, very simple. Let's take a look here at a problem. 1/2 plus 3/5. Now we know that when we're looking at denominators, these are different, 2 and 5. We're going to find the least common denominator, a number that both 2 and 5 are factors of or can go into, which would be in this case 10. What we would do then is multiply each fraction by a fraction of 1, and then we would multiply them together. So we get 5 times 1 is 5, plus 3 times 2 is 6, all divided by 10. When we reduce it, we'd get 11/10. So this is our basic premise of how we would work with numbers. Now let's add a little bit with variables. And here we have 1 over x plus 1 over x squared. Again, we're going to think about what's the least common denominator. Well, the least common denominator is going to be x squared, because both x can go into x squared as x squared can go into x squared. So we'll multiply this first one by a fraction of 1, which will be x over x. X times 1 is x plus 1, and the whole thing divided by x squared. And that's as simple as this gets. We cannot simplify this because this is a binomial in the numerator and a monomial in the denominator, so they cannot cancel, so this is as simple as it goes. So let's take a look at some steps, and this is how we're going to take a look at it. We're going to determine the least common denominator first, which is denoted by the letters LCD. We're going to multiply each rational expression by a fraction of 1 to get the common denominator. Then we're going to add or subtract the rational expressions, and when we say add or subtract, we're referring to the numerators, because we're going to keep the new denominator. And then we're going to rewrite the rational expression, which means we're basically going to simplify it as low as we can. Let's take a look at a problem here. And we have 1 over 3x to the third plus 7 over 2x squared plus 3 over 6x. Now when we look at this, we want to determine what is the least common denominator. Well, in looking at the numbers, 3, 2, and 6, and also the variables, we know that 6x to the third will fit that bill. What we need to determine now is what will we multiply each of these terms by in order to get 6x to the third. The 3x to the third, we would multiply by 2. The 2x squared, we would multiply by 3x. And the 6x, we would multiply by x squared. So we're going to multiply each of them by a fraction of 1, as denoted here. And then multiply our numerators now. 2 times 1, 3x times 7, and 3 times x squared. That will give us 2 plus 21x plus 3x squared, all divided by 6x to the third. Let's rewrite the numerator in descending order, and we'll get 3x squared plus 21x plus 2, all divided by 6x to the third. This does not factor any further, so then this is as simple as it gets. Let's take a look at another problem here. Here we have binomials in our denominator, 5 divided by x minus 2 plus 7 divided by x minus 6. So we're going to think about the least common denominator. And this is similar to our first problem we looked at when we had denominators of 2 and 5. Neither of them went into the other. Well, the same thing is true here. We have binomials x minus 2 and x minus 6. They're prime. They do not go into each other. So what we're going to do is we're going to need one of each, and that will be our least common denominator. So what we'll do is we'll multiply this first fraction by x minus 6 and the second fraction by x minus 2. Here we have that, and then we just got to make sure when we're multiplying it times this number 5, we're going to distribute it out. So that becomes 5x minus 30, and the other one would become plus 7x minus 14. We're then going to combine like terms, 5x plus 7x, which will give us 12x, and negative 30 minus 14 is negative 44. We need to keep on going and factoring until to make sure that we don't have anything else to cancel. And in 12x minus 44, we can factor out a 4, leaving us with 3x minus 11 divided by x minus 2 times x minus 6. So we're going to take a look at some problems and actually work them out slowly through, all the way through. And if you've got your notes out, let's get going. Here we have a squared divided by 2 plus 3a squared divided by 8. Once again, we want to find the least common denominator. Realize that it's 8, and so this first fraction we would have to multiply by 4 over 4 because 4 times 2 is 8. Once we do that, we get 4a squared plus 3a squared in our numerator, and in our denominator we would get 8. We would continue by adding like terms in the numerator, 4a squared plus 3a squared, which would give us 7a squared, and we would divide it by 8. This does not simplify, and so this would be as simple as it gets. Looking here at a second problem, 2 divided by x plus 5 divided by x squared, we'd think about the least common denominator. It would be x squared. Since this one's ready to go, we would multiply the first one by a fraction of 1, which would be x over x. We would then start to build our fraction numerator. 2 times x is 2x, plus the 5, and our denominator would be x squared. This is as simple as it gets because the numerator is a binomial and the denominator is a monomial. Taking a look at another problem here, x minus 2 divided by 6 minus x plus 1 divided by 3. We're going to take a look and say what's the least common denominator, and that's going to be 6, which means we need to multiply this second fraction by a fraction of 1 of 2 over 2. We need to keep in mind a couple of things. First of all, this is a subtraction problem, and this is a binomial. So when we distribute this 2 out, this 2x plus 2, which is what it will become, it'll change signs because of this minus sign, so keep that in mind. Our numerator, x minus 2, so instead of positive 2x, because of that, will be negative 2x, and instead of positive 2, will be negative 2, and our common denominator of 6. We're going to collect like terms. X minus 2x is negative x, and negative 2 and negative 2 will give us negative 4, all divided by 6. This is not going to reduce any further, so this is as simple as it gets. Looking at our next problem here, 7 divided by 3x plus 15 minus 4 times x plus 5. We have two binomials and they are different, but what we need to do is factor out one of the binomials to see what's really going on. Here we factor out a 3, we end up with 3 times x plus 5, that represents 3x plus 15, and here we just have an x plus 5. Well, this is kind of like those other ones. We need both of those. 3 times x plus 5. That is our least common denominator. That being the case, that means we need a fraction of 3 over 3 for that second fraction to be multiplied with it. So then we'll take our new denominator, which is 3 times x plus 5, and our numerator, which would be 7, minus 4 times 3, which is 12. 7 minus 12 is negative 5, and we're going to divide that by 3 times x plus 5. Again, binomial, monomial, no cancellations. So this is as simple as it gets. Here we have another example, 3 divided by x minus 1 plus 2 divided by x minus 1 squared. We have to remember what x minus 1 squared means. That means x minus 1 times x minus 1. Well, since we have 2 of them here and 1 of them there, we know that our least common denominator is going to be that x minus 1 times x minus 1. Since there are 2 of them over here, we only need 1 multiplied to that first fraction. We're going to distribute this 3 out, so we'll have 3x minus 3, and then add the 2, and that will be our numerator, and our denominator will be x minus 1 times x minus 1. We're going to combine like terms. Here we're going to apply negative 3 and positive 2 together, which would give us negative 1, and divided by x minus 1 times x minus 1. Now we cannot cancel this 3x minus 1 with anything because in order to cancel binomials they need to be exactly alike. These are not exactly alike, so there's no other canceling that's going to take place. This next problem here, we have 3 minus b divided by b minus 7 plus 2b minus 5 divided by 7 minus b. We need to realize that we have opposite signs going on. Here we have a positive b and a negative 7. Here we have a positive 7 and a negative b. Well, we know that if we multiply this first one, denominator, if we multiply it times negative 1, we can reverse the signs. We do that now that we have the exact same signs. They both have negative 7s and they both have positive b's. So in order to get rid of this negative 1, we need to factor our negative 1 out of the numerator as well, which will change it to negative 2b plus 5. Let's bring down the rest of the problem here and see what's going on. So what that does is cancel these negative 1s. Now with these gone, we have a common denominator. We have like denominators. So we can automatically just write b minus 7 and write down all the terms we see in the numerators. 3 minus b plus a negative 2b. So I'm going to change that sign. Plus 5. We're going to combine like terms. Negative b minus 2b is negative 3b. And 3 plus 5 is 8. And we're going to divide that by b minus 7. Nothing's alike, so we're not going to cancel anything. Sometimes it's easier if we can kind of catch little things like this. That way we don't have to be multiplying binomials all over the place. Here we have 2 divided by x minus 1 minus 2 divided by x plus 1. Well, in this case, yes, the 1's are opposite signs of each other, but not the x's. They're both positive, so we won't be able to do what we just did a moment ago. So basically what's going on is our least common denominator, we're going to need one of each, x minus 1 and x plus 1. So let's multiply this first one times x plus 1, and the second one here by x minus 1. Again, we want to make sure we note that it's a subtraction problem, so when we multiply 2 times x minus 1, we want to change the signs afterwards to denote that. Our numerator here, 2 times x plus 1 is 2x plus 2, and here, instead of positive 2x, we'll get negative 2x. Instead of negative 2, we'll get positive 2. And then our denominator is x plus 1 times x minus 1. We're going to put together things that are alike. 2x minus 2x is 0. And 2 plus 2 is 4. So our numerator is 4, and our denominator stays the same at x plus 1, x minus 1, and nothing cancels. We have one more problem to do. Here we have 8x divided by x squared minus 16, and we're going to subtract 5 divided by x plus 4. We have to recognize what x squared minus 16 factors into. It factors into x minus 4 and x plus 4. That being the case, this is going to be our least common denominator. So we need to multiply the second one then by x minus 4. Remember to keep in mind that this is a subtraction problem. So we want to make sure that we're putting the right terms in the numerator. We're going to keep the 8x. 5 times x is 5x, but I need the opposite of it, so it's negative 5x. 5 times negative 4 is negative 20. The opposite of negative 20 is positive 20. Again, our denominator, x plus 4 times x minus 4. We're going to combine like terms. 8x minus 5x is 3x. We get 3x plus 20 divided by x plus 4 and x minus 4. There's nothing else I can factor out of 3x plus 20, so that's as simple as it's going to get. So hopefully this helped explain a little bit more about adding, subtracting rational expressions with unlike denominators.